Hey, sixth graders. Module 13 in our textbook and the unit that we've been going over, which is Unit 7, talks about everything that we need to know about inequalities. What are they? How do we use them? And how do we solve problems that have them included in them? And part of how we use them is how to graph them. So this video is going to go over all of those things, and hopefully you'll have a better understanding of it when we get through the flashcards that I've made. Okay, so let's talk first off, what is an inequality? What are they? Well, it's nothing more than just a math sentence that uses symbols to relate two different expressions. Inequalities use these symbols. I know you're used to seeing these. We've used them since elementary school, but sometimes it's good to have a refresher as to what they look like and what they mean. This symbol is greater than. This one means less than. And it all has to do with the direction in which the point goes. This one looks just like the greater than symbol, but you'll see a line underneath it. That means there is an equal component to that inequality. So these two symbols actually mean greater than or equal to, and less than or equal to. So those are the symbols that we use, and it's nothing more than a math sentence to compare two expressions. So from there, let's look at something that I think a lot of kiddos have been asking questions about. What is the big difference between an inequality and an equation? Because y'all know with our algebra unit we've been doing equations for a very long time. Well, equations use an equal sign to show the relationship between both sides. And when we have that equal sign, it shows us there is only one solution to the problem. Inequalities use those different symbols that we just talked about to show you there's not just one answer to the problem. There can be an entire group or an entire set of numbers that make the statement true. And that's why we graph them on a number line, to be able to see what is that entire set that we're talking about. In order to solve and graph inequalities, we need to know what we're going to use. Well, we use a number line. We're used to using number lines. We've been doing it all year long. But we graph on a number line using an endpoint and an arrow. In geometry, would actually call this a ray, but since we're using it on a number line, I'm calling these an endpoint with an arrow. Now you might notice that on one of them, I have the hole or the endpoint colored in. One of them I don't. And in class, we've called that the donut holes, to where you either have a plain donut or you have a jelly-filled donut. And you know when you graph them which one to use based upon the symbol that is in your inequality statement. If you simply have a greater than or less than symbol, that is telling you this is the number that we're comparing everything to, but the number that you've put the endpoint on is not part of the solution set. The jelly-filled donuts tell you just the opposite. They say, okay, we have an equal component here. We're coloring this in because if we draw a number line, whatever number we put that endpoint on, we're saying that actually is part of the solution set. So you use a jelly-filled donut only when there is the equal component to the problem. Okay, so now let's get started on some examples and let's put all of this together. Here is our first example. This is the math sentence. This is the entire inequality. Some of you have been trying to say, okay, well my answer is -5. Guys, I'm sorry, this isn't an equation. And we can't have just a single number. The whole point to an inequality is to say there is a whole group of numbers that tells us it can be part of the solution. And what I'm going to do is use a highlighter to make it more visible which way our arrow is going to be going. So if this is our problem, we have W, which is our variable, is less than negative 5. Well, let's find where negative 5 would be on a number line. Here's negative 5. Here is positive 5. And let's do one number on each side of it. We're going to use that to compare. This tells me W is less than negative 5. Negative 5 is the number that we're comparing everything to. So my donut hole is going to be placed at negative 5. Now here's the question. Which direction makes this statement true? So I'm going to look to the left and to the right of those numbers. Is negative 6 less than negative 5? Yes. Is negative 4 less than negative 5? No, it's bigger because it's closer to 0. And so that means my arrow is going to go to the left. Now here's the trick. Don't forget the trick I showed you. Whenever you solve an inequality, if the letter is on the left, the way that the arrow is pointing with the symbol tells you which way your arrow is going to go in your inequality number line when you graph it. So I'm going to have an open donut hole, and my arrow goes to the left. Now let's look at another one. This one says 6 is greater than R. But guys, my brain doesn't see these the right way. I know that this actually means R is greater than 6. And so I always like to move the letter to the left and then use the trick that we just talked about. In order for us to do that, I'm going to have to remember what part of the sign is open to R, and it's the big side. So if I'm going to put the letter on the left, I have to make sure that the big side of the symbol is where it's supposed to be with the R. And then I'm going to bring my 6. So the number in play here is 6. Let's see where 6 would be. If this is 0, this is 3, this is 6, and this is 9. This is negative 3, and negative 6, and negative 9. Since the number in play is 6, I'm going to put my donut hole right there at 6. Now let's use my trick. I can't use the trick on the original one because my letter's not to the left. But with my letter being to the left, this sign tells me, okay kids, my arrow is going to go to the right. But let's test it. If R is 3 bigger than 6? Nope. Is 9 bigger than 6? Yep. So that's our clarification. And we have a plain donut hole because we do not have the equal component to our inequality. Now this next one is a little bit different because this has a rule that you guys also know. We never, ever, ever want a negative variable. And right here you'll see that x is negative. We don't want that. We always want our variables to be positive. So what we have to do is a little bit of algebra to make that happen. We have to take this negative x and move it to this side of the inequality to make it positive. We want it to cancel out. In order for it to cancel out, it has to equal 0. So if we have negative x, I'm going to have to add x to both sides to maintain balance, but this is going to cancel this out because negative x plus x is 0. But now I don't have anything on this side of the inequality. So what I have to do then is the second step of taking this 3 and moving it over here. Well, in order for this 3 to cancel out and be equal to 0, this is a positive 3. I have to subtract 3 from both sides. Now, these 3's cancel out. So what I'm left with is my x, which is positive, is less than or equal to negative 3. So now let's graph it. Here's 0, here's 3, here's negative 3, and again we'll go ahead and put a negative 5 right there just to kind of help us out, make sure we're doing it the right way. Here's the trick. Is our letter to the left? Yes. So, in the inequality, this arrow tells us which way our arrow needs to go on our number line. Well, the number in play is -3. So here is my donut hole. And because we have an equal component to our symbol, that donut hole is going to be filled in. That means -3 can be a part of the solution set. X has to be less than or equal to -3. So every single number that is less than or equal to -3 is part of the solution to that inequality. But remember, we never want a negative variable. Now, this is the last thing we learned about inequalities. The rules change when you multiply or divide by a negative number. When you multiply or divide both sides by a negative number, you must reverse the sign to make the statement true. Let me read that again. The rule changes when you multiply or divide by a negative number. You must reverse the sign to make the statement true. So I have two problems in which we're going to do that as examples with. We have 11 is greater than -3 times y. If you remember how we did our equations, I'm going to do our house just like we usually do. If we have this as our house, because 3, since it's stuck right next to the letter, those are family members. Those aren't friends. But we want our family members to leave and we want to be all by ourselves. I have started off with multiplying, so my chimney is going to be a multiplication sign, which lets me know whatever I do here to both sides has to be the opposite of multiplication. If I am multiplying times -3, in order to cancel those out, I have to divide both sides by -3, because -3 divided by -3 is 1, and that leaves us y just by itself. So now I have y is less than 11 divided by -3. That's going to be a decimal. I probably should not have done that. It's going to be -3 2/3. We can still graph that. But look, because we divided by that negative number, this sign can't look like that. We actually have to make sure we reverse it in order for the statement to be true. So instead of it being a greater than symbol, in order for the problem to be correct, we have to change it. So now y has to be bigger than -3 2/3. So here's 0, here is -3 2/3, and here is +3 2/3. Well, if y has to be bigger than -3 2/3, here is my number in play. Everything is going to have to go to the right, because every number bigger than -3 2/3 is closer to 0 and goes to the right. The last problem we're going to do is this. Negative x divided by 5 is less than or equal to 12. Okay, guys, here's my house. I'm starting off with division, so that means I'm going to multiply both sides times something. I'm going to have to multiply both sides times -5 to cancel that out. That leaves me with x over here, and 12 times -5 is -60. But remember, I can't just bring my sign down. I have to change and reverse its direction. So if here is 0, here is -60, here is +60, x has to be greater than or equal to -60. So here's my donut hole. It's going to be filled in. And since my arrow is pointing to that direction to